Dear students, now next, after discussing the physical properties, we will discuss the chemical properties of ether. Now, due to presence of dash O dash bond, the ether are almost inert. Right? Under ordinary conditions, they are not going to react. But there are certain reactions which are being possible for with these ethers, and one of it is the breakage of the C dash O bond. Right? So which bond? That is C dash O bond. So students, we will discuss here reaction involving the cleavage of C dash O bond, right, of the ethereal oxidation. For it, let us have the reaction of ether with halogen acid, right. So if the reaction condition is cold, we have got low temperature, and halogen acid taken is less, that time student, it is CH3, CH2O, CH2, CH3, that is diethyl ether, where it is made to react with HX, let it be HI here. That time we will get CH3, CH2I plus CH3, CH2OH. That means we are going to get an alkyl halide and we will get a alcohol formed, right? And here at that time the temperature is less cold, HI is present in less quantity. But if the temperature is increased, if we increase the temperature and student HI is present in excess, right, that time student we will get only alkyl halide. The alcohol which was being formed, it will also get converted into the alkyl halide, right. Now in this reaction student, we have got the two things to be kept in mind. The first one is that the HI, that is halogen acid, the reactivity of the halogen acid will be maximum for HI in this way. So HF we are not going to count here, right. We will only count here students HCl, HBr and HI. Cl among these three have got the least reactivity, then HI has got the maximum reactivity, right. Now student, we will just see the mechanism of this reaction, and then we will come to know about the second important thing that I wanted to tell you, that which two things we have to keep in mind. The first one was regarding the reactivity of the halogen acid, and second one is, now first after the mechanism I will be telling it at the end. Student, the first step is the mechanism. It is the protonation of ether, right. The first step will be student the protonation of ether. So here if we have taken CH3, I have taken CH3, CH2O, CH2, CH3. So this is the protonation, and it is understood that how it is going to take place. We have got HI, which is giving the H plus, right. So this HI is coming from the HI, right. So here oxygen has got the lone pair on it, so we will get it formed in this way: CH3, CH2O, and this is CH2, CH3, and this is H. The protonated. This one we have got the oxonium ion formed here. This is the first step. Now second step is the attack of nucleophile. So which one is the nucleophile here? Student, it is the I negative, it is the nucleophile. Right, it is going to attack it. Now we will write it as CH3, CH2O, this is H here, one lone pair, the positive charge on oxygen atom, this is there. Now student, the I negative, that is acting as a nucleophile, right, it will attack the oxonium ion from the side, right, which is living, right. So this side has to get removed, this side. So it will be attacking from the opposite side, right. It will attack from this side, right. So what will happen here? So we will get here CH3, CH2, I formed, and we will get here CH3, CH2, OH. This is the reaction when we have taken the HI in less quantity, right? Here the HI will be in the less quantity. But if the HI is in excess, that time student, so I am rubbing it from the top here. So this is the third step here. So if HI is in excess, that time student, this CH3, CH2, OH, right? If HI is in excess, so what will happen? Again the protonation will take place. We will get CH3, CH2O, this is in this way, right? And I negative will be released. And the next step will be the I negative plus CH3, CH2, this is OH, and this I negative is going to attack on the carbon, and you will get CH3, CH2I plus H2O. So you can see that we will get the two molecules of alkyl halide formed when we take HI in excess. So which mechanism student is taking place here? It is taking here the SN2 mechanism, right? It is following the SN2 mechanism. You can also show here at this second step, you can get the, in this step student, here you can show the intermediate step also, formation of an intermediate. So I am showing it here. So what will be that intermediate? Here it is in this way that we will have, this is oxygen, this is H, this is CH2, CH3. You can, it is in this way. This is carbon, H2 here, right? CH2, and this carbon, it is having this CH3 also, CH3, CH2, right? And the I negative will be also getting linked to it, right? So we can also show it in this way, CH2, this is CH2, CH3, carbon, and you can show at the top also this CH2, and this is carbon is going to have here a pentavalent status coming 1, 2, 3, 4, 5. Here the old bond, here the old bond is breaking and the new bond is forming. So this is the intermediate which you can show here, and then you can show the breakage of this bond, and you can show this product formation, right? So this is it. Now student, here now I will tell you about the step which I wanted, the thing which I wanted to add here. I think this is clear. Now the thing is that if we have a tertiary part is there, okay? If a tertiary, here you can see that we are having the primary on both sides. But if we have a tertiary alkyl group, right? Now let it be in this way. I want to tell this case to you. This is very, very important. This is there. Now if the HI will react to it, now student, tell me that which alkyl halide will be formed here. Here students, we will get only alkyl halide, right? The alkyl halide we will get here and an alcohol, right? So which one it is going to be? Student, it will be CH3I plus, and the tertiary part student will form the alcohol, right? We will get the halide formed, right, of the smaller group, and this halide will be formed, right? Halide will be formed of smaller group. And second thing is that in that time it is going to follow the SN1 mechanism. If we have any of the alkyl group as tertiary, that time the SN mechanism will be followed, right? That is the carbocation generation. And you know that the tertiary carbocation which will be formed is going to be the stable one, right? So this is the important here, that if a tertiary alkyl group is present in the ether, that time it will follow the SN1 mechanism, and the product will be the alkyl halide will be of the smaller alkyl group. In this case it is of the methyl iodide it is getting formed, right? And instead of this, if any other examples are there, if you are having a benzene ring instead of this group, that time also student, the product alkyl halide will be formed of the smaller group, right? So let me tell here that if we have anisole, let it be listed OCH3, and HI reaction is there, excess also, with less or excess, whatever we will have only one product, we will get phenol form, and CI group will be moving to that of the smaller sized alkyl group, right? So this is very important reaction students, and go through it properly. So students, next chemical properties that ether shows. So the electrophilic substitution reaction is nitration. So when the anisole is treated with nitrating mixture, that is concentrated nitric acid and H2SO4, we will get the product substituted at ortho and para position by the electrophile NO2 positive. So we will get NO2 group introduced at ortho, and another is at the para position. So when we will name it to become, it is 2 nitro 1 methoxy benzene, right? Similarly, we can write it as 4 nitro 1 methoxy benzene. So the product formed will be ortho and para substituted product. Now next is the Friedel-Crafts alkylation. Here also this is anisole OCH3 treated with alkyl halide CH3Cl in presence of Lewis acid, anhydrous FeCl3. We will get alkyl group introduced again at ortho and para position, right? So here we are getting, it is ortho, at ortho position we have the CH3 group, it is orthomethyl anisole, methyl anisole. In the same way it is para methyl anisole, right? So in a similar way, in the same way, protyl graph acylation will also take place, right? So the electroanisole, that is the alkyl, the benzene ring having an alkyl group, right? It undergoes the electrophilic substitution reaction. Okay, so just get it completed. So here today we are completing the unit alcohol phenol and ether, right? And from next day we are going to start the next one. Thank you.